Now that we've gone through the rules and properties of logarithms, let's go ahead and practice applying these so that we can get comfortable in the next section using the properties to solve equations. So notice in the examples in front of you, all of these examples have logs written only once. I only see one log in this expression. So that means it's in condensed form. So we are going to expand it. So when we expand it, we're going to then see more than one log in the expression. So in example 1, I have the natural log of 8 times a times b. I'm going to break up that 8 in AB into two separate products, or two factors. I have this factor and this factor. And if you look back at your rules, the product rule says that I can split this up using addition. So I'm going to rewrite this as natural log of 8 plus natural log of a times b. Now this isn't completely finished yet because I still have another product in here. So I'm going to split up that a times b, and I'm going to have natural log of 8 plus natural log of a plus natural log of b. So now this is completely expanded, and I can tell that it's completely expanded because with each log I only have one factor. And I also don't have any exponents up here that I would have to bring down in front. So if I had 8 squared or a squared or b squared, then I would have to continue to expand it. When we expand, we don't want exponents up where the 8, the a, or the b is. We want all of that pulled down in front. So this is completely expanded. So this is condensed form because I only see one log. And then this is expanded form, and I have more than one log. Okay, looking at the second example, I am going to be using the quotient rule. I have 14 divided by 15 in there, so according to the quotient rule, I can write it as subtraction. Now, remember with the quotient rule, the order matters, so I want to make sure that 14 goes first. So I have log of 14 minus log of 15. Now I have no exponents for the 14 or the 15, and I don't have any other factors in there with the 14 or the 15, like a 14x or a 15y, so I know I'm completely done expanding. Okay, example 3, I only have one factor in here with the 2 to the a. However, I want to make sure it's completely expanded, and part of expanding is to make sure that whatever is inside here doesn't have any exponents as well. So using my power rule, I'm going to use the power rule to bring that a down in front. So this a here can come down in front. So I'm going to write it as a log 2. Now it's completely expanded. Okay, in the next example, we have multiple steps here. Now it's going to start getting a little bit tricky and we have to take our time. Okay, so we have multiple things going on here in example 4. We have negative exponents, we have quotients, and we have products. So we're going to be using multiple rules. So the first thing we're going to do is split this up into a subtraction problem. Log of the top minus log of the bottom. Okay, now the next step after you do your division, you want to do multiplication. So I'm going to split this up. Now here's where it gets tricky. It's not hard, but it's easy to miss this step, especially if you're rushing through. So I'm just going to carry down the log a to the negative 7 minus. Now, this expression here is going to be rewritten as a sum because I have a product here. And I'm going to split up that b to the negative 10 and that c to the 9. However, this is where students tend to make a mistake because they're rushing through. I'm subtracting this entire expression, but this entire expression is going to be equivalent to log b to the negative 10 plus log c to the 9th. And a lot of times, students forget to put parentheses or brackets around that expression to remind themselves that they actually have to distribute that negative. So it's actually minus log base b to the negative 10 minus log c to the 9th. And that is where the little mistakes throw people off. So just take your time and make sure you put parentheses in the right places so that you don't make those mistakes. Okay, so now I have it so that I have multiple logs, but my last step is to make sure that I don't have any exponents up here. See, I have an exponent here, here, and here. If I still have exponents when I'm expanding, I'm not done. I want those exponents to be pulled down in front. That should be the last step, is to pull those exponents down in front and make them coefficients. So this is going to be negative 7 log A. So the minus and the minus make that a plus 10 log B. And then I have minus 9 log C. So this will be my final answer. So this one was a little bit tricky because there were multiple steps and there were a couple places that you had to take into consideration that you had double negatives. But just take your time and follow the rules and you'll be good. Oh, it looks like I copied that example twice. We'll skip example 5. Let's go on to example 6. When you're dealing with logarithms and you see roots in your expression, what I recommend is the very first thing that you do, change your root and rewrite it as an exponent. So the square root is the same thing as raising something to the 1/2. So I'm going to rewrite this as log base b of x to the 4th, y to the negative 10th to the 1/2 power instead of the square root. Then what you can do is when you raise a power to a power, so when I raise these powers to the power of 1/2, you multiply. So I'm going to rewrite this as log base b. If I take 4 times 1/2, that's going to give me x to the 2nd. And then if I take negative 10 to the 1/2, that's going to give me y to the negative 5th. So we can use our rules of exponents to simplify those roots before we even start expanding. And then that will make it easier when we actually go to expand. Okay, so now I have a product that I have to worry about, and I have exponents to worry about that I need to expand. So first, let's break it up. Take that product and break it up as a sum. So I have log base b of x squared plus log base b of y to the negative 5. And now my very last step is to make sure that any exponents that I have up top have to come down in front so that it's considered completely expanded. So I have 2 log bx plus, actually that would change to a minus because I'm bringing the minus 5 down, minus 5 log base b y. And now it's completely expanded. I don't have any products and I don't have any exponents.